Okay, so we have another easy problem on LeetCode, which is removing duplicates from a sorted array. You must have already read the description by now. It's a long description with some examples. Basically, we are given a sorted array of numbers such as 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, and there are a lot of duplicates in it. And finally, we have to manipulate this array in place, which means no extra memory, to bring all the unique elements in front of the array and return the length of all the unique elements, which means total number of all the unique elements. So basically the first 5 elements of this array should be modified to 0, 1, 2, 3, 4, which means 0, 1, 2, 3, 4 here, and we should return 5, and it doesn't matter what the rest of the array looks like, right? So it seems to be a simple problem with which can be solved with two pointers manipulation. So we maintain a iterator I which loops over all the elements of the array, and we also have a iterator we have a pointer j which will signify what last index to overwrite on. So j means it will be a placeholder where if any unique elements are seen on ith index, we will overwrite it on jth index. And final array should look like this, and the answer should be 5 for this. So how we are manipulating the array? So we have the iterator I and j initialized to 1 because if the array just have less than one number or one number, we can just return um, 1 or whatever the length of the array is. So it doesn't matter, there cannot be duplicates, right? So we always compare I with I minus 1th position to see if the ith element is unique or not. This is very simple for a sorted array. This can be this if ith index number matches I minus 1th index number, that means it is a duplicate. If not, it's not a duplicate in a sorted array. Simple, right? So actually I have this example. Wait, I have, yeah, this is the example. Okay, cool. So here I have 0 and 0 uh, on 0 and 1th index. Let's start by comparing I with I minus 1. So ith element is not unique, so we don't need to overwrite on jth index. We increment I, we see 1 is not equals to its last element 0, which means we need to overwrite 1 on jth index. So we overwrite 1 on jth index and increment j. Now we look at another number, we increment I. 1 is equals to I minus 1th number, so we increment I again, we don't do anything. Same here, now we increment I again. We look at 2. 2 is not equals to 1, which means 2 is the first unique, another unique number we have seen. We overwrite 2 on the jth index and increment j. So now j always points to the last index we can overwrite, safely overwrite on. Now we increment I again because we have processed this 2. This is equals to the last element, so we haven't seen a unique element. Now I see a unique element and I overwrite it on j. I increment I again, no unique element, increment I again, we overwrite on j and increment j. Now j should be equals to 5 here, and which gives us the length of the first uh, length of the half of the array which has the unique elements, right? So how to write in code? So let's define len equals to n to be length of the array, and if n is less than equals to 0, we can safely return n because there can be no duplicates and no manipulation needed. Actually, if it also has 1, then we don't need it. I initialize I equals to j equals to 1, and I iterate over the elements of the array using index I, and I compare if nums of I minus I not equal to nums of I minus 1, which means unique element found. Then we overwrite it on jth index and we increment j, and we also need to increment I every time to iterate over the index, and we return j. Right, so let's just run this on test code. Right, now I want to test my code on this test case, and I always have this problem in LeetCode that I have to manipulate this test case here and then run code result again. Instead, what you can do is, and even it's a helpful tip for interview, when you have to write a unit test case in Python, you can just write assert here, and you want to initiate a instance of solution class, and whatever the name of the function is, remove duplicates. Okay, and you give it the input, right? So you call the function, you give it the input, and you assert its value here, which means equals to 5, and you can safely run code here and you shouldn't see any assertion errors. Okay, this is an assertion error because this already has, this is not sorted. I pasted the final solution here. I should have pasted this one. So the test case was wrong. Our input was wrong. Right, so now this is the test case. Because the input wasn't sorted, our algorithm broke. Right, so no assertion errors here, so this test case passes. Let's just try on another test case where we have something like probably all the unique elements. 1, 2, 3. This should also be equals to 5. Oh yeah, no assertion errors. Right, so let's submit this. Okay, accepted. Cool. So this is a neat trick to test multiple test cases while you manipulate your solution. This is also helpful in interviews when you want to just write a quick unit test. Thank you for watching. Subscribe to my channel for more videos like this. Thank you. Last, actually, I forgot to do the runtime analysis on this and the space analysis. So we were given O1 extra memory only, and we haven't used any array. We have just using some variables n and I and j, which means order 1 of memory. And runtime seems to be, so space complexity seems to be order 1, and runtime complexity is order n, right, where n is the length of the array. So I think this completes our solution actually. Thank you. You can safely subscribe now.